1-to-1 is just anything where y doesn't repeat. Every x you put in gives you a different answer out. And remember, in algebra, we decided that things were 1-to-1 by the horizontal line test. If every horizontal line only hit the graph once, or at most once, then it was 1-to-1. If any horizontal line hit it more than once, it was not 1-to-1. Are the trig functions 1-to-1? No. I mean, think about the graph of sine. Sine looks like this. Is that 1-to-1? No. Cosine looks like this. And really, all of them keep repeating, right? So none of the trig functions are 1-to-1. In order to have an inverse, we need 1-to-1. Inverses, remember we said, are the opposite. All that happens in an inverse is you flip the x and the y. They change orders. So we have talked about how to find those in the past. A few things about it. If x and y switch, then the domain of the function is equal to the range of the inverse. The range of the function is equal to the domain of your inverse. Because x and y flip, so domain and range flip. Graphically, we could find them by reflecting across the line y equals x. Because that's what happens in an inverse. Your x becomes a y, your y becomes an x. And in algebra, when we found inverses, we had all these steps that we went through. Okay, we're really not going to go to that much. We're not doing that much with them here, but it seemed like a good time to review a couple things. So remember, in finding an inverse, it was written in function notation. We changed that f of x to a y. We would switch x and y, solve for y, and then at the end we wrote it with f inverse of x, just to denote that we had found the inverse. Does this stuff sound familiar? Hopefully. We did it last semester. Okay. So here's the deal. To have an inverse, the function has to be 1-to-1. We know that the trig functions are not 1-to-1, right? You keep going around the circle, you keep repeating yourself. That is not 1-to-1. But we can find an inverse if we restrict the domain, if we only take a portion of our trig function. So for instance, if I looked at sine, okay, we know the graph of sine looks like this, and it keeps going, right? And it keeps going both directions. So obviously that's not 1-to-1. But if I just took this little section here, would that be 1-to-1? Yes. So with the trig functions, what we have to do is find that section of the graph. We have to have a section that would show us the full thing of what it looked like. So for instance, for sine, I can't just say a quadrant 1, because that only tells me when sine is positive, right? And I can't say quadrant 1 and 2, because quadrant 2, isn't it just the same as quadrant 1? If you think about your unit circle, your y values, they repeat themselves in quadrant 2. So if I'm talking about sine, I would have to do quadrant 1 and quadrant 4. Quadrant 1 gives me all the positive values of sine. Quadrant 4 gives me all the negatives. So we'll pick 2 consecutive quadrants. When I say consecutive, that means I'll always do quadrant 1, because quadrant 1 would give me the portion that's positive for every single trig function. And then I'll either do quadrant 2 or quadrant 4, because those touch quadrant 1. We will never use quadrant 3 when we're doing inverses. And we'll decide if we're doing quadrant 2 or 4 based on the trig function itself. So when I'm doing an inverse for a trig function, I am finding the angle. If I say sine inverse of 1/2, I am saying where on that unit circle is sine equal to 1/2? Tell me what the angle is. So that's what we're doing with these. So I'm going to introduce this. I put a box for each trig function. We are not really going to use all of this, but I want to kind of explain it a little bit. There's 2 different notations for an inverse. You might see sine to the -1, or you might see arc sine. Both of them mean the same thing. It's meaning find the angle. If you think about normal sine, okay, you don't have to write all this down, but just for talking, we know the domain of sine goes forever, right? Negative infinity, positive infinity. But we said if we're going to get a positive and a negative, we'd have to do quadrant 1 and 4. Can we agree on this unit circle? 3 pi over 2, isn't that the same as negative pi over 2? So my domain, the x's, would be from negative pi over 2 to positive pi over 2. And we know the range of sine, it only hits things between negative 1 and 1. So you notice on the inverse, the domain of the inverse is the range of the original function. The range of the function comes from the domain of sine, okay? I left blanks for you to write this down. It is not something that I am really going to focus a lot on. Okay? I am not going to come to the test and ask you for the range of sine inverse. That's really not what I'm worried about. The thing that I really care about is right here, the quadrants. This is what you need to know. When I'm talking about sine inverse, I have to be in either quadrant 1 or quadrant 4. Because sine inverse for sine is positive in quadrant 1 and negative in quadrant 4. That is the thing that I will be asking you on every question. The ordered pairs, the graph, I just kind of put it here to show you in case you encountered it. If you think about when we graphed sine, okay, we did ordered pairs. Sine of 0 was 0, sine of pi over 4 was radical 2 over 2, sine of pi over 2 was 1. The inverse is just flipping those. So if you ever had to graph them, just taking those points off your sine graph and flipping x and y. All right, so on each of these, I left spaces for you to fill in domain, range, and quadrants. All I really care about is your quadrants. You have to know which quadrants the inverse functions live in. All right, so let's kind of look at some problems. I am asking you to find y. Does everybody have a unit circle in front of them? So if you need to look at something, you can. Okay, what this means, you have to understand the meaning of an inverse. If you want to write this without the inverse, if you want to move the sign to the other side, it just drops the y. This is saying sine of y equals 1/2. You are just finding the angle. I'm saying where on that unit circle is sine 1/2. Now we know it happens multiple times, but sine inverse can only be in quadrant 1 or 4. In which of those is it positive? Sine is positive in quadrant 1. So looking on my unit circle, or thinking about your hand trick, in quadrant 1, when is sine 1/2? 30 degrees, or pi over 6. Normally I'll specify if I want degrees or radians. If I don't tell you, you can give me either. You don't have to give me both. Right, so the answer to an inverse is an angle. You are just answering questions about that circle. But the key to it is you can only get one answer. You're not telling me every time sine is 1/2. Just one time. And that's determined from those quadrants. So if I ask for sine inverse of -1. Okay, if you want to write this without an inverse, that means sine of y is -1. We know sine inverse can only be in quadrant 1 or 4. And which of those is it negative? 4. So I'm saying on that circle, when is sine -1? Yeah. So we could write this several different ways. We could say 270 degrees, which is 3 pi over 2. If you're looking in the book, it's going to tell you this is -90 or negative pi over 2. Is that any different? Mm-hmm. They're coterminal, right? So you could have any of those answers. We should recognize now that -90, if I add 360, I get 270. So it's just two ways of identifying the same angle. All right. So if I look at this, if I wanted to write this without the inverse, it just means sine of y equals -2. You know, sine inverse could only be in quadrant 1 or 4, and it's a negative, so it's quadrant 4. I am asking you to find the angle when sine is -2. Look at your unit circle. Sine is the y. When is y -2? Never, because sine can only equal things between -1 and +1. So what would I write? No solution. There isn't a case. But we're limited to those quadrants. So if the original problem has an inverse, the answer you give me has to be in quadrant 1 or 4. All right. So let's talk about cosine. We know the graph of cosine, right? Looks like this. So if I want a positive and a negative section, which quadrants do I need? 1 and 2. That would give me the positives and the negatives. So that's the key on that. Your quadrants, 1 and 2. I put the domain, range, ordered pairs, just to kind of show you how they're related to the normal cosine, but that's not the thing that I really want you to remember. Fill them in on your sheet, but what you need to know is your quadrants. Problems. Y equals arc cosine of 1. Arc cosine means cosine inverse.
Cancel that. No baseball dismissal.
There wasn't one. That explains it. So what this means, if you want to write it without the inverse, to move the cosine to the other side, you just drop the inverse. So it's saying cosine of y is equal to 1. You are finding the angle when cosine is positive 1. In which quadrant is cosine positive? Quadrant. Okay, so you're looking at that unit circle that you have. Cosine is the x. When is x equal to 1 between quadrants 1 and 2? 0. So we can say 0 degrees or 0 radians. If I said 2 pi degrees or 2 pi radians or 360 degrees, those are the same thing. Do you guys understand what I'm doing with these inverses? So the answer to an inverse is an angle. The key, you only get one answer. So we have to know which part of the circle to look at. All right, so if I said y equals cosine inverse of radical 2 over 2. Cosine inverse, it has to be in either quadrant 1 or 2. Which of those quadrants is negative? 2. Okay, so I am asking you, when is cosine of y negative radical 2 over 2? So we're looking in quadrant 2. Cosine is the x. When is x negative radical 2 over 2? And I guess I should ask, could everybody fill out a blank unit circle on a test if you needed to, so you have one to look at? We need to refresh that at some point, maybe? Okay, we'll practice that, maybe Monday. Make sure we know. All right, y equals cosine inverse of 1/2. What quadrants can it be in? 1 and 2. Okay, which one is it positive in? So what this means is find the angle so that cosine of y is positive 1/2. When is that? 60 degrees. All right. So now I'm going to throw the other 4 functions at you. Again, I put domain and range on there, but that's not really what I'm worried about. The quadrants is what you have to know. Cotangent and tangent. It's kind of, both of those are positive in 1 and negative in 2 and 4, right? So we pick our quadrants like we did when we were graphing. When we graphed tangent, we graphed it from negative pi over 2 to positive pi over 2, right? So tangent is going to be like sine. It will be quadrants 1 and 4, just like we used when we were graphing it, because that's what gave us asymptotes on the ends and a nice solid graph in the middle. Cotangent When we graphed it, what quadrants did we do? Or where did we graph when we did an interval for cotangent? 0 to pi. So that's quadrants 1 and 2. So cotangent is going to go with cosine. Be quadrant 1 and 2. Does everybody have what they need off the tangent slide? Secant and cosecant, they're going to follow their reciprocals. So, we done with cotangent slide? Secant is the reciprocal of what? Cosine. So it's going to go with cosine and be quadrants 1 and 2. And that means cosecant, the reciprocal of sine, would be 1 and 4. The graphs look a little weird because they have asymptotes in the middle. Remember that from when we graphed? Every time sine or cosine was 0, you had an asymptote. So those graphs look a little bit different. But again, what we really need to get from this is the quadrants. We have to know which quadrants to pick from when we're talking about inverses. Are we done with the secant slide? So this time I'm asking for degrees. So when I look at this, I see arctangent, and I'm immediately thinking, okay, tangent inverse could be quadrant 1 or 4. What I'm asking you is when is tangent theta equal to 1? If it's a positive 1, which quadrant are we in? 1. Okay, so you can think about your hand trick, you can think about your unit circle, tangent's y over x. When is tangent 1? If I say secant inverse of 2, secant can be in which quadrants? Okay, which one is a positive 2? Which one would we be positive? So what this means is secant of theta is equal to 2. Now I don't know about you. Secants, cosecants, cotangents, they take me a second longer to think about. So what I usually do is just flip it. Think about the reciprocal. That means cosine is 1/2. When is cosine 1/2? 60 degrees. Okay, so all of this comes back to the hand trick or the unit circle. That's what we're going for. Are those okay? We have done inverses on our calculator before, like back at the beginning, but we only did positives. So here's the thing. If you put a negative angle in your calculator, you will get the right answer most of the time. The problem comes with tangent and cotangent because we don't have a cotangent button, right? So if I want to do anything with cotangent, I have to enter what? Right, tangent. It's a reciprocal of tangent. But here's the problem. If I'm doing inverses, tangent inverse is in quadrant 1 or 4. Cotangent is in 1 and 2. So it will give you the wrong answer. So what I tell people, instead of trying to remember, is this the one that's going to give me the wrong answer or not? Just enter the positive and do it like a reference angle. And then move it to whatever quadrant you need. So let's try a couple of those and then we'll be done for today. So, if I said find y in radians, so we're in radians, if y is equal to cosecant inverse -3, in what quadrants does cosecant inverse exist? In which of those is it negative? Okay, what this means cosecant of y is equal to -3. Now, do we even have a cosecant? No. So cosecant is the reciprocal of sine. So that means sine is -1/3. Okay, is sine -1/3 anywhere on our circle? No. So what I'm going to do is get a reference angle. I'm going to type it in as sine inverse, and I'm going to do the positive 1/3. Because I don't want to remember if it's giving me the right answer or not. I'm just going to do it the same every time. Make sure you're in radian mode. And then type in sine inverse, so second sine 1/3. Did 0.3398. Did everyone get that? That's what I was saying. I'm doing the reference angle, so I'm always doing the positive, so I don't have to worry about if it's giving me the right answer or not. Then, what quadrant do I need that to be in? Quadrant 4. So there are two ways we could get this in quadrant 4. So we could do, we're in radians, so 2 pi minus 0.3398. So 5.9434. Or if you caught it, in quadrant 4, would it just be a negative 0.3398? So you could give me either of those. Now I know on this one, if you had entered sine inverse of -1/3, it will give you that answer. But I'm telling you, long term, this is a better solution because you will be less confused later on. Okay. Yes. We did the sine inverse, so second sine. You're in degree mode. Then to put that quadrant 4, you need to recognize it just as negative. I mean, it's the same way. It won't make a difference. Okay. Next one, I'm asking for degrees. So switch your mode into degree. Okay. This is the one that if you enter it with the negative, you'll get the wrong answer. So it's saying cotangent of theta is -0.3541. We don't have a cotangent button, so that means tangent is 1/that. So to get your reference angle, we'll do tangent inverse of 1/the positive. And I got 70.5009 degrees. But we know cotangent inverse could be quadrant 1 or 2. And which of those is it negative? 2. How would I put this in quadrant 2? If you do that, you get I'm almost done, but I'm going to stop here for today. Example 5 I'm going to save for Monday. Okay, so I've done most of it. For those of you that'll be gone Monday, there won't be too much more. I'm going to put the homework up. I actually thought we might look at the first couple together. It's just a fill in the blank about inverses, so it's kind of back to last semester, see what we remember. And then give you guys some time to practice. So this homework is technically going to be due at the beginning of class on Tuesday. We'll spend part of the hour Monday on this section, finishing the last few examples and giving you a chance to ask any questions that you had. And then I will also start the next section on Monday. Technically at this point you could do everything except 79, just so you know. But 1 through 6 we're going to look at real quick together. 14 through 66, every other even. Okay, so it's like 14 problems. It sounds like a lot. I really need to stress the every other. It's not as bad as, I know, 14 problems. I don't know if it's really that many.
I can't count.
So it's not two.
It's like 14, 18, 22, 26.
So every four, okay, then just.
Yeah. Do you need me to write them out?
I don't know what time it is. What is that?
Just add 4 every time.
Does anybody know what time?
We don't say that. We don't say that. We're doing. Teacher just tells us to do it.
Oh, you're so amazing.
That seems like more important.
It feels like she wants to rub it in our face.
It's your opinion. Why does it seem like more important?
You're a genius. You're smart. Everybody.
I was close. Alright, take a look at 1 through 6. Let's just talk about those real quick. They are fill in the blank. The front page of your notes packet might be handy for that.
I'm okay with that.
Opening your book is very helpful for
Good
that.
start.
Alright, I'm not just giving you the answers though, you guys have to tell me.
1 to 1.
So, for a function to have an inverse, it must be what, Grady?
1 to 1. Dude, you like little thingy like 1.
Yeah.
Just a lot of people
Okay. Number 2, the domain of y equals arc sine of x equals the blank of y equals sine x. Range. Because we're looking, the domain of the inverse is the range of the original function. Arc sine is the inverse, sine is the original. Okay. Number 3, y equals cosine inverse of x means x is equal to cosine y. If you want to write it without the inverse, you just move. So if it's y equals cosine inverse of x, to move that cosine to the other side, you drop the inverse. So cosine y is equal to x. Number 4, the point pi over 4, 1 lies on the graph of y equals tangent x. So therefore, what point would be on the graph of 1 pi over 4? It's on tangent inverse. Yeah. Or arctangent. So inverses just flip the order of x and y. Alright. Number 5. If a function f has an inverse and f of pi is equal to -1, then f inverse of -1 is equal to
No.
Negative 1.
so it's saying
Oh, wait.
f of pi is -1. Yeah. When you do the inverse, those two just flip. So f inverse of -1 is just pi. Alright, and the last question about inverses. How can the graph of f inverse be sketched if the graph of f is known?
A section?
Flip the x and y on the.
Okay, so if you look on your little packet,
Y equals x. X
the
equals y.
second bullet,
Oh, x equals y. Y equals x.
yeah, it's reflect across y equals x. Or like what you said, you could take every point, flip x and y and graph it. But we know they're symmetric across that line. Okay, that was kind of the weird little section that's more about inverses.
Number 4.
Now you're just finding inverses. So think about your quadrant and your unit circle.
Wait, it's not